Welcome back, Mindsetters, on this lovely Saturday morning. Guys, again, I stress, enjoy your youth day, but make sure you also understand it and what it actually means. Ask your parents. I know it seems like your parents weren't youth, but they were at some point. So make sure you ask them and find out more about today. And guys, again, call in on 0861 058 262 and you could get one of these packs sent to you. So guys, also keep posting on the page, If you lost any, if you need help, make sure you get those questions on the page so I can get them to John. But for now, I'm going to hand back to John. John, take it away.
Thanks, Ty. Yeah, guys, Youth Day is really important. You know what? It's all about education. That's where it started. And we're here today because of the courage and the bravery of your parents and many of the young people back there in 1976. So let's get going and make sure that we don't give up because of what was done for the struggle in those days. It's about you getting involved in your struggle to improve your fate in education as well. So let's get going with these questions. We're looking at the 2008 exam paper, and we're going on to our next question. We've done some stuff on rates of reaction. We're going on to redox, and the tie between redox and electrochemistry is really important. So let's make sure we've got these basics in place. Redox, remember what redox is. Redox is broken down into two parts. It's reduction and oxidation. And we're looking at reactions in which these two half reactions take place. That means that there is a transfer of electrons. You need to understand it. You need to be able to identify what is oxidation, what is reduction? How are you going to remember it? Well, there are lots of little ways of doing it. The way I remember it, the way I was taught, and the way that I still remember it is the following. And I just want to make a note of it. That I say reduction is a gain. So I write the word R-I-G, reduction, R-I for is, gain, G. Spells the word rig, R-I-G. Oxidation is a loss, O-I-L. So you've got oil, rig. Oil, oxidation is loss, reduction is gain. If you remember that, you won't have a problem. You'll always get it right. But we've also got an interesting thing. We've got a table that's given in every exam. Now, I've just got a big one blown up here because I need big writing to read, going a bit blind, or short-sighted, at least far-sighted. So I've got the big table here to make sure that we refer to it. This question actually refers to it. It's table 4 and 4A and 4B. We'll be having a look at that just now. The table is also very useful in determining which things are more likely to undergo oxidation and which ones are more likely to undergo reduction. Make sure you're familiar with the table because the table is very useful. I use table 4B and I remember the reducing agents, the things that undergo oxidation are on the right-hand side. And we'll come to that shortly. Right, let's have a look at the question. It says, rusting is an unwanted reaction happening around us. It's an unwanted redox reaction. Iron rusts when exposed to oxygen and moisture. And the unbalanced ionic equation for the one reaction that occurs during rusting is represented below. So what we've got here is iron as a solid, oxygen as a gas, and some water. And then we're producing iron 2+ ions in solution. That should really be a superscript. And hydroxide ions as the ionic reaction. Now, it then says, use the table of standard reduction potentials. That's the one on the data sheet, the big one at the back of the data sheet. Make sure you're familiar with the one that use one. Don't change between 4A and 4B. The one I prefer is 4B because I look to myself and I say, where is lithium? Where is potassium and sodium and lithium? And they're at the top on the right. Where is fluorine? In fact, fluorine is the one that you know always. It's the strongest oxidizing agent. It's bottom left. Okay? So F2 and lithium at the top, F2 at the bottom. bottom left, top right. And you've got then you know where you're at. So we now need to write down the oxidation half reaction. Now, guys, oxidation is a loss of electrons. The thing that undergoes oxidation is known as the reducing agent. Reducing agent always donates electrons, so it's losing electrons. So it is the thing that undergoes oxidation. It makes reduction happen to the other stuff. So if I was a reducing agent, I would want to donate something to Ty, who might be undergoing reduction. He's going to gain the electrons. I'm losing, he's gaining. You got it? Hope so. So we want to get the strongest reducing agents. Now, think about it now. In all the chemistry you've done, which elements are most likely to lose electrons? What's the metals? The non-metals tend to gain electrons. So we're going to look amongst the metals. We've got here a metal, iron, oxygen and water, and we're producing hydroxide ions. And we're producing iron 2 plus ions. So even without looking at the table, just from my knowledge of chemistry, I'm going to start to identify what is the most likely reducing agent. Which is the one that's most likely to undergo oxidation? I think it could be the metal. And so we recognize as well, without even looking at the table, we can do this, and we can say to ourselves, we know from grade 11 work that the oxidation number of iron is 0. As an element, oxidation number is 0. Okay? It's neutral. Oxidation number of iron 2 plus is plus 2. So what's happened to go from 0 to plus 2? Well, it's lost electrons. What is oxidation? Loss of electrons. So here we go. Without even looking at the table, you can confirm it by looking at the table, but I'm going to recognize from this that I've got iron to start with, and I've ended up with iron 2 plus in aqueous solution. How did I get there? Well, I lost some electrons, and I've got iron 2 plus 2 electrons. And there's my oxidation half reaction. Now, if you go to the table, and table 4b, I know you won't be able to see it. What you're going to do is you're going to go to the right-hand side. On the right-hand side, you go down the page until you see the one, either oxygen or iron. From the top, I get to iron. First, above oxygen. And then what I'm going to do is I'm going to read from right to left, and I write it from right on this side. It normally reads the other way around, but I turn it around and I start with the iron on the right hand side, and I'd be able to write it down as iron goes to iron 2 plus in aqueous plus 2 electrons. Easy one to get going. Let's move on to the next one. Write down the name of the substance that is reduced. Okay, so let's go back to the equation, and we recognize here that we've got oxygen starting at 0. So I just want to change the numbers, because oxygen as a substance is an element. It's a neutral molecule. It has an oxidation number of 0. And it's forming oxygen over here. The only other thing that I can see here is oxygen, and it is at -2. So what's happened to the oxygen? I hope you can see, if I start at 0 and I get to -2, I've become more negative. What does that mean? Become more negative? I've gained electrons. Got it? If you gain electrons, what was a gain of electrons? Reduction. Reduction is a gain, oxidation is a loss. Now, don't get confused. Because it's becoming more negative, you might think, well, that's losing. No, becoming more negative is gaining a negative thing. It's gaining the electrons. So it's undergoing reduction. So what substance is undergoing reduction? We are asked to write the name. Now, guys, the examiners are sometimes a little bit fussy about this. They've said name. Please don't write down the formula. What was the stuff that undergoes reduction from the equation? We can see it's O2. What is O2? It's oxygen. So write down oxygen. Don't write down anything else. Don't write O2 or O, oxygen, and you could even write down gas if you really wanted to, because it said O2 with a G. So oxygen gas is the thing that is undergoing reduction. It's being reduced. Right. Next. Perform a calculation to verify, that means to explain, to confirm that this reaction is spontaneous. We know it's spontaneous. It's happening around us. We know that if we leave some iron nails with some water on the surface out in the air, it's going to turn that brownish color. Iron rusts in air. Happens. We don't have to put a fire underneath it. We don't have to increase the temperature. We just have to leave it out in the air, and over time it will rust. So, but how can we confirm it? Now, this is where the table of half reactions comes in, and it's really useful it's really useful for us. What we need to do is we need to confirm the two half reactions, and we use the table to read off data from those half reactions. So I'm going to go back to my table, and I'm going to write down my half reactions. So let's do that. I'm going to say iron goes to iron 2 plus 2 electrons, and I'm going to say oxygen. Now on the table I need to look up oxygen on the left hand side, and we'll find it as we look it down. We recognize that we want the one that goes to OH on the other side, OH minus. So oxygen plus some water, H2O, plus 4 electrons, there was 2 of those, gives us 4 H minus. Let me just make sure that you can see that. I want to just rewrite it, so write it a little bit bigger. I'm going to erase that one, but I want to just get it a bit bigger because I squashed it up. 4OH minus. Good. Okay, so there are my 2 equations. This one I've already the top one, first one, I've changed around. Second one is the one that was with the oxygen. I've just read those off the table. This is undergoing oxidation, and this one is undergoing reduction. And you can see it. Look, it's gaining 4 electrons. So we know it's gaining electrons is reduction. Guys, what you need to do next is you need to go and look at the table and fill in the values here that are known as the E0 values. These values come from the electrochemical cells. We fill those values in and then do the calculation. I think we need to go to a quick break, and while you go to the break, I'm going to pick up the values and we'll set up the calculation. And back to you, Ty.
All right, so mindsetters, as I've been saying earlier, make sure you get posting on the page. Keep posting, because guys, the more frequent you're on the page, the higher your chances of getting one of these sent to you. But guys, also, I stress, make sure you keep chatting to each other. If you see a mindsetter and they're struggling, make sure you at least do your best to help them out. But you know what, guys, for me, I'm going to say, see you after this quick break.